This should be the last quadratic equation formula practice problem that we're going to go through in the math section. And this one's asking, again, we have an RLC circuit, so we have some sort of combination of resistor, inductor, and capacitor, and it's given to be by this equation, this transfer function, the characteristic equation. And it's asking, first we solve for the roots. This isn't so clear. The values of the roots aren't so clear. You can't exactly do this one. The way you do this is you use the quadratic formula. Why is that? Well, you can't exactly factor this one. I keep saying exactly. You can't factor this at all, really. So what you need to do is you need to do -6 plus or minus square root of 6 squared minus 4 times 1 times 25 over 2 times 1. Remember, minus b plus or minus the square root of b squared minus 4ac. And so what we get is, we already noticed this is going to be a complex number, complex root. So we can plug this into our equation or our calculator. Something to remember is make sure your calculator is FE approved. You can look at it on their website. Just make sure, because some of them won't be approved. So we have to be careful about which ones we can use. And that's besides the point now. What we have here, we have the two roots. We have two complex roots. That's our answer for part A. Now for part 2, part B of F right here, it's asking, is it underdamped, critically damped, or overdamped? The way we do this is, and this is not in the straight line or in the quadratic formula part. This is on page 58 in the second order linear homogeneous differential equations with constant coefficients part. This is telling us here that if the determinant, or sorry, not the determinant, if a squared is greater than 4b here, the solution is of the form of this, and it's overdamped. What we notice here is the complex. When the solution is complex, if a squared is less than 4b, the solution is underdamped. So what we can then go to, we could go to the saying right above. The roots of the characteristic equation are this, and can be real and distinct for a squared is greater than 4b, real and equal for a squared is equal to 4b, and complex for a squared is less than 4b. Underdamped is for when a squared is less than 4b, or the equation is complex. So what do we have here? Well, we have an underdamped solution. The roots are underdamped. So that would be our answer here. You will see some problems in the practice exam asking what kind of dampness it is, and it goes along with the roots of your equation. So sometimes they don't ask for what are the roots. They just ask, is this overdamped, underdamped, or critically damped? You have to solve for the roots and see, is it complex, real and distinct, or real and repeating? Anyways, this is how you would solve this problem. Hopefully this helped. And thanks, guys.